Alright, so it's November 2024, ordinary level chemistry of the Zimsec exam board. So always remember to subscribe to our YouTube channel so that you get be notified whenever we post anything on the YouTube platform. We are carrying out massive topical revisions in preparation for the examinations. So this is the paper for the Zimsec exam board. So we have section A, where you are required to answer all the questions, and then section B, where you are required to answer 4 questions. If you are doing Zimsec, you need to stick to the instructions, the candidates, and if you are not doing Zimsec, what you only need to do is to pay attention to data, right? So for section A, we are required to answer all the questions, right? And then number 1 says, state any 3 properties of a mixture that can be separated using steam distillation. So here we don't mainly focus on creaming answers, but we want to broaden our foundation, trying to explain any concept within the given radius, right? So here we are being required to explain properties of a mixture that can be separated using steam distillation. So steam distillation is defined as a separation technique that can be used to extract temperature sensitive compound, especially essential oils from plants, right? So the definition for steam distillation, it is a separation technique that can be used to extract temperature sensitive compounds, especially essential oils from plants, right? So this is the definition of the steam distillation. So how does steam distillation works? So steam distillations are the principles of steam distillation. So here, steam distillation. So first, steam is passed through the material, right? So steam is passed through the material to be analyzed. For example, the flowers, right? And then volatile compounds will evaporate. So volatile compounds will evaporate. So volatility, we're going to explain the trends of volatility when we are doing periodicity, right? So the volatile volatile compounds will evaporate with the steam, right? With the steam. So this is where the real reaction is taking place. And then the vapor mixture, right? The steam and the oil, right, is condensed, and then it is collected, right? And then oil and water separate because they are immiscible. So this is the whole process of steam distillation. So a question arises which says, why are the significance of steam distillation? So steam distillation allows distillation below 100 degrees Celsius, right? It allows distillation below 100 degrees Celsius. And then it prevents the decomposition of delicate substance in the compounds, right? It prevents decomposition of delicate substances, right? So this is the significance of steam distillation. So for example, we can use it to extract eucalyptus oil, rose oil, and then clove oil, right? So this is an example where we can use a steam distillation. So you need to know the general method of steam distillation, the advantages and the disadvantages, the significance, and the whole process of steam distillation. So here we don't stick to the given question as I've alluded to, but we try to explain anything that can be examined within that radius, right? So we are back to our question, which says three the question says 3 properties of a mixture to be separated using steam distillation. So first, the mixture must contain volatile organic compounds, right? Volatile organic compounds. So volatile organic compounds. So volatility to separate compounds that can evaporate easily when mixed with steam, right? And then the next one, they must be miscible with water, right? This is the second. And then why? Because the organic components must not dissolve in water, so that it can allow the separation to be into distinct layers. And also the third point, we can say thermal. It must be thermally unstable, right? At higher temperatures. High temperatures. So it must be thermally unstable at high temperatures, right? So compounds that decompose at their boiling points can be separated at lower temperatures using the steam distillation. So still, you need to take note of that. Steam distillation is used for mixtures like plants, essential oils, and water immiscible organic compounds. You need to take note of this one. That steam distillation is used for mixtures like plants, essential oils, and water immiscible organic compounds, right? Immiscible organic compounds. So this is the general properties for steam distillation, right? And then we move on to the next part. So the next part says the interconversion of the states of carbon dioxide can be represented as below, right? So we have carbon dioxide in the gaseous phase to carbon dioxide in the liquid phase. So this process of changing carbon dioxide from gaseous phase to liquid phase is represented by this equation X. And then from liquid phase to the Y phase, from the liquid phase to the gaseous phase, it is represented by the Y reaction. So this from gas to liquid, it is called condensation, right? And then from liquid to gas, it is what we call evaporation or boiling, right? And then we're required to state the conditions needed for the process A, for the process of condensation. So for condensation, we need low temperature, right? And then for the process Y, we need high temperature, right? High temperature. So this is the general application, right? And then so the question says condition or conditions, right? So we can say high pressure here, and then low pressure here. So these are the conditions, right, necessary for the processes. And then we move on to the next part of the question, which says describe the changes that occur in terms of arrangement of particles and the energy of the particles during the process X. So the process X is what we call the condensation. So the particles lose kinetic energy, right? And then the movement will decrease, right? Decrease in movement. And then the particles are going to be closer together. And then the intermolecular forces between the particles are going to increase, right? So the intensity of the intermolecular force will increase, right? Intermolecular force will increase. So this is the changes that will occur. And then we're now moving on to number 2. So number 2 says some group 2 elements are represented by X, Y, and Z were placed in a 15 cubic centimeters of dilute sulfuric acid. The number of bubbles produced after 3 minutes were recorded. The number of bubbles produced after 3 minutes were recorded. And then we have this table showing the results. So we have element X, element Y, and then element Z. And then you've got the number of bubbles 10. So here we've got 10, and then here we've got 37, and then here we've got 2. And then state with the reason the least reactive element. State with the reason the least reactive element. So we are told that group 2 metals react with the dilute sulfuric acid. So M plus dilute sulfuric acid, this is the general equation to form M sulfate plus hydrogen gas. So this is the general equation for the group 2 metals with dilute sulfuric acid. So state with the reason the least reactive. So the least reactive is the one with the few number of bubbles, right? And then the most reactive is the one with the highest number of bubbles. So Z is the least reactive. Why? Because it produces few bubbles, indicating that the reaction is very slow, right? So this indicating that the rate of reaction is slow, right? So this is the explanation. So the hydrogen gas is evolved in small amounts. And then we now move on to this part number 2, which says describe and explain the effect of using what acid, right? So what acid, meaning to say we've increased the temperature. So the effect of increasing temperature, according to the Boltzmann distribution curve, increase in temperature will increase the number of particles with energy equal to or higher than activation energy, thereby increasing the effective collisions. So increasing using what acid will result in the increase in the rate of reaction, right? Describe and explain. So that's the description. And then the explanation: at higher temperatures there is increase in kinetic energy of the particles, leading to frequent and effective collisions, right? Increase in kinetic energy leading to more frequent effective energetic collisions, right? So for particles to react, they must have sufficient energy, and they must collide in the correct orientation. So first we need to have energy, sufficient energy equal to or greater than activation energy, the minimum amount of energy needed to start a chemical reaction. And also the particles must collide in the correct orientation. So you need to know these two factors, right? And then state the effect of doubling concentration. So the effect of doubling concentration will cause the rate of reaction to increase. So rate of reaction to increase, right? So why? It's a higher concentration. It will provide more protons, right? Acid will dissociate to form the protons, which are the reacting ions in the reaction, right? So increasing the concentration of the acid will increase the concentration of these protons, right? So the protons will increase per unit volume, right? Will increase per unit volume, thereby increasing the frequency collisions, thereby increasing collisions, right, for the reaction to take place, right? So you should know the reaction kinetics by heart: the Boltzmann distribution curve, the effect of a catalyst, the effect of temperature, effect of concentration, and then the effect of the catalyst, right? So we're now moving on to part number B. So part number B, we are told a mass of Z, 0.48 grams of Z, produces 560 cubic centimeters of hydrogen at RTP. Write a balanced equation for the reaction. So we've written the equation here. So the reaction, this is the reaction, right, for Z. So for the reaction with X and Y and Z is the same, since they have got the same electronic configuration. So chemical equations are governed by the electronic configuration at the valence shell. So since they're in the same group 2, they have got same reaction but with different reactivities, right? So you need to take note on that one. So we are using Z. So it's Z plus dilute sulfuric acid, Z plus sulfuric acid to give Z sulfate plus hydrogen gas. So this is the equation, right? And then we have to balance the equation. So we've got 2 hydrogen. So Z group 2 metals will form divalent ions with the +2 charge, right? So with the sulfate 2 minus, so the 2 goes here and then the 2 goes there. So you need to check on our playlist the video we illustrated on how to write chemical formulas. So this is the correct formula of Z sulfate. And then we've got 1Z here, and then 2 hydrogen, 1 sulfur, 4 oxygen, and then 4 oxygen atoms, right? So this is the balanced equation, right? And then deduce the identity of Z. So we are required to deduce the identity of Z using this given information. So we are given the mass of Z that reacted and the amount of hydrogen that is produced. So using the given information, we can say that we can deduce that 1 mole of this Z metal will give 1 mole of the hydrogen gas with a reaction with sulfuric acid, right? So 1 mole of hydrogen gas at RTP for the Zimsec example is equal to 28 cubic decimeters, and then for the Cambridge it is equal to 24 cubic decimeters, right? So you need to stick to your exam board, right? You need to stick to your exam board. So always remember that. So for the revision purposes, we don't normally attend to the examples, but we want to understand the concept, right? So we can say 1 mole produces 28 cubic decimeters, the mass, the volume of 1 mole of a gas under RTP, right? Since we are doing the Zimsec paper. And then 1 mole is equal to 28 cubic decimeters, right? What about 560 cubic centimeters? So to change these cubic centimeters, we can say divide by 1000, right? So you have 0.56 cubic decimeters. So 1 is equal to 28 cubic decimeters. What about less is equal to 0.56 cubic decimeters, and then is 1 multiplied by 0.56 over 28 cubic decimeters, 1 more here. So we are going to have go straight to our calculator. 0.56 divided 0.56 divided by 28, we're going to have 0.02 moles, right? So 0.02 moles for the element Z. And then we are given the mass of Z. So we are going to apply this formula Mn is equal to mass over Mr. So we want to calculate the molar mass, right? So N we've got 0.02, and then the mass we've got 0.48, and then the molar mass they are known. So X, the molar mass, is equal to 0.48 over 0.02. So X is equal to 0.48 divided by 0.02, which is equal to 24. So the molar mass 24 is the mass of magnesium. So you need to know these fundamental equations for the stoichiometry, right? So N is equal to mass over mr, and then mr is equal to mass over n, and then mass is equal to n by mr, and then we've got n is equal to cv, and then c is equal to n over v, and then v is equal to n over c. You need to know these equations for your stoichiometry, right? So the identity of M is the magnesium metal, right? With the relative atomic mass of 24 and the atomic mass of 12. So magnesium, the nuclide notation, this is the magnesium atom, right? And then we are moving on number 3, which says the chemical reaction takes place in a breathalyzer is shown, right? So we have this ethanol plus oxygen to give ethanoic acid plus water here. So you need to add water. Here. Name the type of the reaction. So this one is not a combustion reaction, it is an oxidation reaction, right? So oxygen should be in the square brackets to show that it is not a combustion reaction, it is an oxidation reaction. Name the type. So this is the oxidation reaction, right? And then name the organic reactant. So this one is ethanol, right? Ethanol. Why? Because we've got this formula, C2H5OH, right? So this is ethanol, 2 carbon atoms, right? So you need to know your organic chemistry inside out. Name the homologous series to which the organic product belong. So this is the organic product, ethanoic acid. So it belongs to the carboxylic acid, right? Carboxylic acid. So you need to know the definition of the term homologous series: a group of organic compounds with the same functional group or same reactions and differs, successive members differs by the CH2, right? CH2. So you should know the definition, and also to know the definition of the functional group, hydrocarbons, right? Because they are frequently examined in examinations, right? And then we are on the part B. Name the part labeled A. So part B says Fig 3.1 shows the structure of a substance formed when animal fat reacts with sodium hydroxide. So this is saponification, right? And then we've got A here and then our B here. Name the part labeled A. So A is the hydrocarbon chain, the hydrophilic part, the hydrophobic particle. So it is the hydrocarbon chain, or the hydrophobic hydrocarbon chain. Hydrophobic meaning water hating. So hydrophobic, water hating. Hydrophilic, water loving, right? Philic, water loving. And then B, it is what we call the carboxylate ion, or the carboxylate group, which is hydrophilic, water loving. So this is the these are the parts, right? Describe how the substance shown in Fig 3.1 removed state. Describe how this removed state. So you need to take note on this one. So the hydrophobic tail attaches to the grease or the dirty substance, right? The grease, the oil, right? So the hydrophobic, the first step, hydrophobic tail attaches to grease or oil, right? And then the hydrophilic head interacts with the water, since it is water loving, and then this one is water hating, right? Interacts with the water. So the hydrophilic head interacts with the water molecule, right? And then it forms micelles that emulsifies it, right? Emulsify it, thereby allowing it to be rinsed off, right? Thereby allowing it to be rinsed away. So this is how the soap functions, right? First, we have got the hydrophobic tails, which attaches to the grease, and then the hydrophilic head, which interacts with the water, forming micelles which emulsifies dirty and thereby allowing it to be rinsed off. So this is how the soap functions, right? So you need to take note of these points, right? So we are now moving on to the next question, right? Explain why the substance is ineffective in hard water. Hard water is defined as water enriched with the nutrients magnesium and calcium, right? So it is water enriched with magnesium and calcium. So why is it ineffective in hard water? So hard water contains the ions calcium and magnesium. It forms the insoluble scum, right? It forms the insoluble scum with the soap, right? Thereby reducing the cleaning ability. Right? So we are done. We're now moving on to number 4. So number 4 says Fig 4.1 shows the annual amount of nitrogen dioxide in air in a certain country over a period of 10 years. And then this is the graph, volume of nitrogen dioxide in air against the number of years. So nitrogen dioxide is this formula. And then we have dinitro tetraoxide, and then we have got the nitrate ion, the nitrite ion, the nitronium ion used in the nitration of benzene. So you need to know the structures of these oxides of nitrogen. You need to know the structures, the displayed formula for the dotted cross diagrams of these ions, right? So we have a video also on that one explaining how these atoms bond with nitrogen being the central atom. Alright, so explain why the amount of nitrogen dioxide in urban areas is generally higher than in rural areas. So in urban areas, we've got more vehicles which produces the nitrogen dioxide from the oxidation of nitrogen, right? And also in the industries, right? So more vehicles and industries where there is oxidation of nitrogen. So in the engines, that's where the nitrogen dioxide is produced, right? And then why is the amount of nitrogen dioxide always greater than 0? Why is it always greater than 0? So it can be also produced from the natural sources, like from lightning, right? From lightning, volcanic eruptions or volcanic activities. Also certain continuous human activities like farming, right? So we can say farming, that's another source for nitrogen dioxide. And then we are now moving on to the next part. Suggest why the amount of nitrogen dioxide became constant in 1988. Suggest why the amount of nitrogen dioxide became constant in 1988. So I want to confirm from the graph. So for 1998, yeah, so the amount becomes a constant here, right? So why it becomes a constant, it is due to the implementation of pollution controls like the catalytic converters, right? So implementation or introduction of pollution controls like the catalytic converters, right? Catalytic converters in the cars, right? Catalytic converters in the cars. So I want to highlight to you how the catalytic converters work. So we want to first complete part B. So the next part says describe the environmental effects of incomplete combustion of fuels. So there is production of carbon monoxide, which is a very toxic gas, right? So carbon monoxide binds to hemoglobin in an irreversible reaction, forming what we call carboxyhemoglobin, which reduces the oxygen transportation in the body, right? So you need to know the effects of carbon monoxide in the body. And also there is a soot. There is production of soot, which causes respiratory issues, right? And also reduces visibility. So soot causes respiratory issues and also reduce visibility. And then unbent hydrocarbons can also contribute to ground level ozone and ozone depletion and smoke formation. So unbent hydrocarbons, which contributes to ground level ozone and smoke formation, right? So we are moving on to number 5, right? So number 5 says the pH values of the 4 solutions A, B, C, and D are shown in the table 5.1. So here's the table with the solutions and then the pH value. So pH is defined as the concentration of hydrogen ions within the solution, right? Concentration of hydrogen ions within the solution. So this is the formula to calculate pH, right? And then the smaller the pH, the higher the acidity. And then pH of about 7 is the neutral. And then above 7 it is the basic pH, right? And then this is the question which reads identify the solution that is a strong acid. So the lower the pH, the higher the acidity, right? So meaning to say C is the solution which is strong acid. And then number 2 says identify the solution that can be used to neutralize sodium hydroxide. Identify the solution that can be used to neutralize sodium hydroxide. So to neutralize this alkaline solution, we need a basic oxide. So this makes A false, because it is a strong basic solution, of which to neutralize we need an acidic solution. So we're going to take option C or option B, right? So we say B or C. So for option B, it is safer and it is more controlled for neutralization, like in practical settings for titration and minor spills. But option C, it is more aggressive and can be maybe too strong to be controlled neutralization. So it needs caution to be used, right? So we give option B and option C. And then identify that can be used for cleaning purposes. So for cleaning purposes, we normally use option D. We normally use option D, a mild alkali, or option B. So option B is used for mild. So we used B or D. So option B can be used in mild cleaning, and then D can be used in industrial cleaning, right? So these are the answers. And then we are now on number B, part 1. State 1 any 2 properties of an acid. So an acid it reacts with the carbonates to give salt plus water plus carbon dioxide. So effervescence of carbon dioxide and then reacts with a metal, to give salt plus hydrogen gas, hydrogen gas. And it also this is hydrogen gas, right? It also reacts with a base. To give salt and water only, the neutralization reaction. So it also turns blue, litmus, red for the indicators, phenolphthalein, colorless in the phenolphthalein, right? So you need to know the indicators. So you've also a video on that one, right? And then explain why rust knife can be cleaned with a piece of fresh lemon. So rust knife cleaned with a piece of fresh lemon. So the lemon contains what we call the citric acid. So lemon contains citric acid. So citric acid can react with the rust, which is iron 3 oxide, right? So can react with rust, which is the iron 3 oxide, right? So this is the chemical formula of rust to form a soluble sodium citrate, right? To form a soluble ion, it's ion citrate, thereby removing the stain. Removing the stain. And then we are on the last part of section 8. Outline the preparation of ammonium sulfate. So there's this question which was also examined, which says write the chemical formula of ammonium sulfate. So this is the ammonium ion 1 plus, and then the sulfate ion 2 minus, the 2 goes there, and then the what goes here. So it's ammonium and then the sulfate ion. So this is the chemical formula for ammonium sulfate. So for the manufacturing of ammonium sulfate, we use the method of crystallization. So the question says ammonium sulfate crystals. So we are going to use the method of crystallization. So first you need to know that for crystallization, we're going to have the neutralization reaction, and then we are going to have evaporation, and then we are also going to have crystallization, and then finally the drying process, right? So for the neutralization reaction, we are going to have ammonia reacting with sulfuric acid to give ammonium sulfate, right? So this is the chemical formula of ammonium sulfate. So we can use the universal indicator, right, to measure the acidity as an indicator for the reaction. We can use our universal indicator as the indicator for the titration, right? And then and then we can stop adding ammonia when the solution becomes neutral, right? And then for step number 2, the evaporation process, right? So we're going to pour the neutral solution into the evaporation dish. So we're going to pour into the evaporating dish, and then we're going to heat gently using a basin burner, and then stop heating when crystals begin to form. So we are going to heat and then stop when crystals begin to form, right? And stop when crystals begin to form, right? And then for the third process, crystallization, allow the saturated solution to cool at RTP, the room temperature, right? Allow the saturated solution to cool at room room temperature. And then we're going to observe crystals of ammonium sulfate starting to form as the solution curve, right? And then the last and the final stage, the drying phase. So we're going to dry by pressing the crystals using the filter paper or warm in a dry place, right? So using filter paper or warm in a dry place, right? So this is the method of crystallization. So you need to know first neutralization, evaporation, crystallization, and then drying. So these are the steps of the crystallization process. And then we're now moving on to section B.